Apartment number 7's on fire. We have reports of multiple people trapped on the second floor.
Traffic 2, shift car 1 responding.
Car 1, 3 blocks out, smoke showing. Deputies rolling up on scene says this is active fire.
Message received. Car 1, come forward, deploy the ultra-high pressure system.
I think everyone needs to see HMA ultra-high pressure systems in action. I think it would make a believer out of anyone.
Is it changing? Is it different than the traditional attack? Are people standoffish about that? Yeah. Was I at first? Absolutely.
You know, I understand the skepticism behind it because it's different when the tradition in the fire service has been to use a lot more water.
Once I understood the science, I understood why the fires were going out. We weren't just getting lucky.
Once you start to understand the science of it and you see how it actually works, fire after fire after fire, it becomes hard to debate it anymore.
People get it. They say, why don't all fire departments do this?
The science of ultra-high pressure is all about surface area.
Ultra-high pressures allow that water droplet to be thrown at such a velocity, creating smaller water droplets, which creates more surface area.
Taking one large droplet and dividing it into 1,000 small droplets, we could create 10 times the surface area. Look at that then in terms of the amount of energy that it can absorb. It can do it a lot faster.
Ultra-high pressure is definitely not high pressure, which is definitely not conventional, but all three work on the same principle of applying surface area.
The laws of physics are not debatable at this point, right? So we sort of have to trust that, well, the science behind it is sound. Nevertheless, people test things theoretically in laboratories, and then the next question is always, okay, but how does it work in the real world? From a science perspective, it makes sense, and I guess in the practical application, I've seen it make sense.
Initial lockdown with the ultra-high pressure system.
We're not trying to say that an ultra-high pressure hand line is a replacement of a conventional hand line.
It's not going to do away with what we already do, but it adds a lot of firepower to what we do.
As long as we're aware of the limitations and advantages of each, they should be a good complement to each other, and it doesn't need to be one to the exclusiveness of the other.
We compare the two simply because that's what people are used to.
First of all, it can be done quickly, which is an advantage. When you can get water on the fire more quickly, that's an advantage, a big advantage.
I've seen the HMA system extinguish fires that using conventional means of extinguishment would have allowed the fire to grow to a much further extent. We were able to extinguish it much quicker.
Not only can we get out the door faster, we get on the scene quicker, we can deploy the hand line quicker, we can deploy the water faster. When you're looking at time as a commodity, it's priceless when it comes down to the time saved on a fire scene.
The vehicle is fully engulfed.
The knockdown capability is staggering when you compare the two side by side.
We're able to flow 30 gallons per minute in comparison to 150 gallons per minute and collect at least the same amount of heat energy.
You're going to use less water, you're obviously going to have less water damage, and we don't end up with water laying on the floor.
It's not uncommon for us to have insurance agents approach us and say, where's all the water? We attribute that directly to the ultra-high pressure system.
We can use the ultra-high pressure to blow through walls, through ceilings. If we have a fire in an attic, we can simply work our way through the sheetrock with the ultra-high pressure to attack the fire.
Long driveways, remote areas, snow-covered roads, you can get through all of that with this system where an engine is going to struggle.
It doesn't tax you the way that a conventional hand line does.
I can get it where I want to go faster.
If we're trying to get there and get it done quickly, HMA is clearly the winner.
Utilizing 1/5 of the water flow, collecting the same amount of heat energy with a greater speed of attack, better application capabilities, safer on the firefighters. I think it's clear why it's become our tool of choice. So our ultra-high pressure hand lines are generally 3/4 inch, flowing anywhere between 20 and 30 gallons per minute through a conventional nozzle that is just engineered to withstand ultra-high pressures.
Our heavy rescue has multiple lines. We have ATVs. Having the HMA line on a rapid response vehicle affords us the opportunity to get the vehicle where the fire is.
You can get at fires and an engine can't.
We'll drive the truck to the back of the structure if the fire's at the back of the structure.
If you're going to be first due in, evacuating car 1, along with fire 1, fire 5, fire attack on the ultra-high pressure system.
During this time, our other vehicles, whether it's an engine, a ladder, a squad, are also on their way, just like they would be even if we didn't have this rapid response vehicle.
You can get there so much faster, and a lot of times knock the fire out well before the engine even gets there.
Fire from the exterior has been knocked down with the ultra-high pressure system, continuing all units.
We use the HMA line and the conventional line on all our fire attacks.
Engine 1 from command, advance to attack line.
Used together, they form a very efficient team. The conventional line is an excellent way to back up the HMA line. We had a fire with 4 rooms on the second floor of an old farmhouse.
We've got flames showing through the roof.
The report from the exterior was fire blowing out second-story windows about 3/4 of the way up the stairs. Started fire attack. We had a ultra-high pressure HMA line flowing 30 gallons per minute.
When I got to the top of that stairwell and saw the amount of fire we were dealing with, I mean, it was intense.
A few moments into the fire attack, we had this thing.
Once we got into the hallway, it was quickly game over.
Bringing that fire under control, we only flowed 140 gallons of water.
It becomes hard to debate it anymore.
I think before anybody should say it doesn't work, they need to try it and actually see what it's capable of doing, and I think they will be surprised.